We will see a demo video for the design of the rectangular water tank container. Okay, so design, program list. Okay, rectangular overhead tank or rectangular underground tank. One. So let us take rectangular overhead tank. This will give the design of the container, right? And not for the staging. Okay. Say first we have to give the input data for rectangular or circular slab that forms the top slab of the water tank. Again, say um, there are say two slabs which forms the top slab of the water tank, rectangular water tank container. And then please remember whatever value you give in the text box, after that you have to press enter key to store the input data. Say for top slab FCK is 20. Right, FCK is 20. F5 is 415. We have two uh, slabs at the top. Say longer span is 5 meter. The shorter span of the first slab is 3 meters. Load is say 8 kilonewton per meter square. Condition is say uh, one long edge discontinuous. Okay, 7. Press and let us take the thickness of slab assumed to be 115, right? Don't worry if you assume a thickness plus please don't assume the thickness of slab to be less than 100 mm, but if that thickness is found to be failed in design, then the computer will increase the thickness. So assume at least 100 mm. Okay, say the second slab which is forming the top slab of the rectangular water tank container is say again uh, 5 meters by 2.5 meters. Okay, and the load is say 8 kilonewton per meter square. Condition is again say 7. Let us assume the thickness of slab to be 115. So this is the input data we have given for the top slab of the rectangular water tank. So just click finish. Yes. Now let us give the input data for the bottom slab of the overhead tank. Okay, now say FCK is 25, press enter. F5 is 415. Again we can take two slabs which are forming the bottom slab of the rectangular container. The first slab is say 5 meters long, 3 meters short, load 25 kilonewton per meter square. Let us take condition again as 7, and let us assume the thickness to be 125 mm. Again the next span is 5 meters long, 2.5 meters is the shortest span. Load is 25 kilonewton per meter square. Condition is 7, and the thickness let us assume to be 125. Okay, now as the data has been given, so click finish. Okay, now we have to give the data for the wall of the containers. So as it is a rectangular wall, okay, so let us assume FCK with 25, 415 is FY, the wall of container. Okay, height is say 4 meters. Okay, press enter. Okay, length of the wall. Okay, say the length of wall will be 5 meters. Okay, and on one side, okay, it is a rectangular wall, so on one side it will be 5 meters, on other side it will be 5.5 meters. Okay, that is 3 plus 2.5. We have taken two slabs. The shortest span for one slab is 3 meter, and the shorter span for the second slab is 2.5 meters. So 3 plus 2.5 is 5.5. Okay, and so the slab, rectangular slab is say of size, total size of the rectangular bottom slab, that is including both the slab, is 5 meters by 5.5 meters. So the length of one wall is 5 meters, and the density is of water is 10 kilonewton per meter cube. And there is another wall with same height 4 meters, length 5.5 meters, and density of water is 10 kilonewton per meter cube. So this is how the data for the wall is to be given. Click finish. Yes. Okay. Okay. So this is the output, right? Output for the top slabs. Okay. Depth considered 115 is found to be okay. Okay. And the depth for the second slab, which we considered 115, was not found to be okay. Okay, so it has changed. Okay, so over here the depth assume is also changed, right? So this is how these are the required depths, right? And this is a design of wall. Okay, and there are two walls. Okay, so the thickness of the wall 1 is found to be 275, and the thickness of the wall second wall is found to be 320. That is required, right? So this is how you can do the design of a rectangular container. Okay, so this is this program only does the design of the water tank container and not staging. Okay, so thank you.